Virtual CCAP is the game-changing innovation the cable industry needs. And in the next 8 minutes, I'm going to tell you why. Over the past few years, I've spoken with a number of MSOs, a lot of you in this room here today, and I've heard a number of consistent challenges. My head end is running out of space, I'm being asked to reduce power consumption and be more green, my revenue per bit is falling, and IP video is inundating my network. Does that sound familiar to all of you guys? Yep. In 2008, IP video represented 14% of US internet traffic. By 2013, that number had grown to over 62%. In that same time frame, total internet traffic grew at an annual pace of 54%. The network simply cannot keep up. Now, the good news is the cable network already has a big pipe. The existing coax infrastructure can easily scale to bandwidths of 10 gigabits per second. The limiting factor are really other aspects of the network. It's the high cost, low performance, and limited reliability of analog delivery, the massive cost of equipment required to scale capacity and the associated power and cooling requirements, and the high cost and limited innovation associated with proprietary technologies. Now, CCAP, the converged cable access platform, was designed to address the cost, power, and space issues. But it just doesn't go far enough. Furthermore, it is burdened by the need to support legacy QAM video when the future is clearly IP. Now, what you need is a solution that allows you to preserve your existing investment while enabling the future. That solution is virtual CCAP. So what is virtual CCAP? Functionally, it is CCAP. It works with the existing OSS and BSS, supports the same set of CPEs, and delivers the same set of services. The big difference is that with virtual CCAP is it completely digitizes the hub. It eliminates the physical CCAP altogether. Let me repeat that. There is no physical CCAP anywhere in your head end or hub in this architecture. Now, the benefits of this are enormous. It addresses your capacity challenges and enables your IP migration. It boosts network performance, it improves reliability, and it radically cuts total cost of ownership, both capital and operating expenses, including power, space, and cooling. So how does it work? Virtual CCAP leverages a software-defined networking approach to deconstruct CCAP and build it in a much more cost-effective and scalable manner. It identifies the base functions so that they can be rearranged and placed in the optimal location and device in the network. Now, broadly speaking, we centralize control and management into the data center or your cloud, and we distribute all cable-specific processing to the node. Now let's take a look at a live virtual CCAP deployment. Over here, representing a head end, we have a half rack of equipment. In there, we have a Juniper MX router that is handling all the IP MPLS and subscriber management functions. Now, routers of this kind are widely deployed in your networks today, and they have all the native capabilities that we need for it to function in a virtual CCAP. They just lack cable-specific awareness. We address that with the virtual CCAP controller, which I'll talk about in a minute. Below there, we have a CommScope CSP platform that is operating as what we call an EtherQAM. In this mode, rather than outputting MPEG video over RF, it packages MPEG video over Ethernet so we can digitally deliver it to the Ethernet node. What this does, it allows you to leverage your existing investments, maximizing the usable lifetime of it, and avoid a costly integration of a new platform specifically for legacy QAM video into your back office systems. Representing the outside plant, we have one of the stars of our show, an Ethernet node. Now, the Ethernet node handles all the RF processing in the system, including the DOCSIS MAC, NFi, and the video PHY. Now, by distributing RF down to the node, we address a number of the challenges you face today. We eliminate distance limitations between the hub and the node, we eliminate timing issues, and most importantly, we eliminate that physical CCAP from the head end or hub altogether. And as the name would imply, the transport is now Ethernet, specifically 10 gigabit per second Ethernet, as opposed to linear analog transport. Now, one of the other stars of our show is the virtual CCAP controller, which resides in your data center or in your cloud. It's a Linux-based application that runs on any off-the-shelf server and is really the brains of our operation. It takes this distributed system and makes it look and feel and operate like an integrated CCAP. It takes every one of these Ethernet nodes and abstracts it so that it looks like a line card in that integrated CCAP system. Now, representing a home or a service group, what we have are 5 24x8 NIC gear cable modems. This could easily be thousands of standard modems or gateways. What we're delivering to that service group is 4 gigabits of DOCSIS capacity, as you can see from the traffic generator output gauge to my right. Now, this can easily scale to 6 gigabits with existing DOCSIS 3.0 technology and to 10 gigabits with DOCSIS 3.1. That's fiber to the home service speeds all over your existing coax. That is the power of full spectrum DOCSIS. Simultaneously, on this screen behind me, we're delivering multiple channels of high-def QAM video. Now, one of the big benefits of virtual CCAP is combining, which is traditionally done in the analog domain, is now done digitally, with this all controlled via software. So we can easily scale this to hundreds of video programs with a simple configuration change. Now, as you can see, virtual CCAP addresses the full array of issues that you face in your network today. It's all digital architecture, increases network performance while improving customer experience. It delivers unmatched capacity and scale at a fraction of the capital and operating expenses. And it's built on an ecosystem of industry-leading technologies, including network virtualization, carrier class routing, and highly scalable video delivery. So let's quantify some of these numbers. The move to Ethernet transport provides you a 10x improvement in fiber efficiency. And when I take the virtual CCAP system as a whole, provides a 55% reduction in CapEx, a 65% reduction in OpEx, a 92% reduction in power consumption, and a 92% reduction in space. Now let's take a look at that last stat. With that half rack of equipment that you see sitting there representing a head end, virtual CCAP scales to support 400 service groups. That's over 200,000 homes passed. If you were to build that with the equivalent architecture with state-of-the-art CCAPs, it would take you 6 full racks. It's pretty clear looking at that where the CapEx and OpEx benefits for virtual CCAP come from. This will allow you to completely reset and reimagine your facilities plans for the future. Virtual CCAP is the key to unlocking the latent capacity of your HFC infrastructure. It delivers a high-performance, scalable, virtualized network that will meet your growing demands, allow you to deliver new services, all at a fraction of your costs. Virtual CCAP is the game-changing innovation the cable industry needs. Thank you very much for your time. Please come visit us in the exhibit hall so we can share more with you. Thank you.